Imagine a single YAML file that can wake itself up in 4 completely different ways, from a git push, from a pull request, from a clock on a wall, or from a button you click in a browser. That's exactly what GitHub Actions lets you build. The secret is the one key at the top of every workflow file. In this chapter, we wire up all 4 triggers together and watch how each one controls when GitHub runs your pipeline and what data it injects into the run. The one key is essentially a menu of events you can subscribe to. You list the triggers you care about, and GitHub does the rest, monitoring your repo and firing the workflow the moment a matching event occurs. The 4 most important triggers in everyday engineering are push, pull_request, schedule, and workflow_dispatch. You'll use push and pull_request dozens of times a week, schedule for nightly jobs and audits, and workflow_dispatch whenever you need a manual escape hatch to deploy or run a diagnostic. The push trigger is the heartbeat of most CI setups. Every time a developer runs git push, GitHub fires this event and your workflow springs to life. Without any filters, it activates on every push to every branch, which is fine when you're learning but noisy in production. The branches a filter narrows it to specific branch names or glob patterns like feature /**, and the paths a filter adds a second layer. The workflow only runs if at least one of the changed files matches the pattern. Push a commit that only modifies a README? With paths, src/**, your test suite stays silent. The pull_request trigger turns your workflow into a code review guard. It fires whenever activity happens on a pull request, by default on 3 events: opened when someone creates the PR, synchronized when new commits land on the PR branch, and reopened when a closed PR is brought back. You can extend this list with the types key to catch other lifecycle events like labeled or ready_for_review. The most common real-world use is running your full test suite on every commit push to a PR so that reviewers see a green checkmark before they approve. The schedule trigger is your pipeline's alarm clock. It uses standard POSIX cron syntax and always fires in UTC. No human needs to push a commit or click anything. You can register multiple cron expressions under the same trigger, so one workflow could run a quick smoke test every Monday at 9 a.m. and a deeper security audit every Sunday at midnight. Just remember 2 important limits: GitHub will delay scheduled workflows by up to 15 minutes during periods of heavy load, and the shortest repeat interval you can request is once every 5 minutes. Adding workflow_dispatch to your run block does something magical in the GitHub UI. A run workflow button appears on the Actions tab for that workflow. Anyone with write access can click it and trigger a run without touching the code base at all. The real power comes from inputs, which lets you define a form with text fields, checkboxes, and dropdowns. Someone deploying to production can select production from a dropdown, check a debug checkbox, and hit run, all through a clean browser interface. Inside your steps, those input values are available via the github.event.inputs context object. The one key accepts multiple triggers simultaneously. You just list them all as child keys. A single workflow file can now react to a developer pushing code, a PR being opened, a Sunday midnight clock, and a manual button click. GitHub runs the exact same jobs and steps regardless of what woke the workflow up. If you need different behavior for different triggers, say, skipping a deploy step on schedule runs, you check github.event_name in a conditional if expression and the value will be the string push, pull_request, schedule, or workflow_dispatch depending on what fired. GitHub Actions gives you 2 complementary strategies for filtering branches. The branches key is an allow list. Your workflow only runs when the push targets one of the branches you explicitly name. The branches ignore key is a deny list. Your workflow runs on every branch except the ones you list. You can't use both keys in the same trigger block, so choose the approach that makes your filter shorter to write. Both support standard glob patterns. A single asterisk matches anything except a /, a double asterisk matches everything including slashes, and an exclamation mark at the start of a pattern negates it. In a monorepo that contains an API service, a dashboard, and a shared utilities library all in one repository, you don't want every push to trigger every workflow. The paths a filter solves this cleanly. List the directories your service owns and your workflow stays completely silent when code changes in a different services folder. Paths ignore gives you the inverse: run everywhere except these paths, which is perfect for ignoring markdown documentation, changelogs, and config files that have no effect on tests or builds. This pattern cuts wasted CI minutes dramatically in large engineering teams. Every time a trigger fires, GitHub injects a full event payload into your workflow run through the github.event context object. The shape of this object changes depending on the trigger. A pull_request event includes the complete PR metadata like title, author, base branch, and label list, while a push event includes the array of commits that were just pushed. The github.event_name string tells you which trigger fired, and properties like github.show and github.actor are always available regardless of trigger type. Pro tip, add a step that runs echo with the to.json of github.event to dump the entire payload and discover every available field. The pull_request trigger has a rich set of activity types beyond the default 3. The closed type fires when a PR is closed, but that includes both PRs that were merged and PRs that were simply declined without merging. If you want to trigger a production deployment only on actual merges, combine types, closed, with an if condition that checks github.event.pull_request.merged equals true. This pattern is the standard way to implement continuous deployment. Tests run on every commit via the push and synchronize events, and the deployment job runs only once the PR successfully lands on main. This distinction exists to protect your secrets from malicious fork contributors. When someone forks your repo and opens a PR, the pull_request trigger runs in the context of the fork with a read-only GitHub token. It literally cannot access your repository secrets. The pull_request_target trigger runs in the context of your base repository with full write access, which makes it powerful but dangerous. If you use pull_request_target and check out code from the untrusted fork, an attacker could insert code that reads and exfiltrates every secret your workflow can access. The safe rule, use pull_request for CI on external PRs, and only use pull_request_target for trusted automation like autolabeling based on PR metadata. Time to put it all together. You need a workflow that runs automatically every Sunday at midnight UTC, no human action required, no code push, just a recurring weekly job. Push triggers need a commit to fire, workflow_dispatch needs a human to click a button, and pull_request is scoped to PR activity. The only trigger that fires on a time-based schedule is schedule with a cron expression. The cron string 00***0 breaks down as 0 minutes, 0 hours, midnight every day of the month, every month, on day 0, which is Sunday. Nail this pattern and you can schedule any recurring automation your team needs.